Hi, AT from CNC at Home. In our last video, we burned out this kerf measuring tool from Lightburn and we measured the kerf on the laser. Here are the results. This is the test that the kerf is actually at 0 degrees, which is kind of odd in that when I initially did this, this is the one I was calling 0 degrees, and it's because I had the pattern this way. The kerf that's being measured, though, really is the vertical one because it's vertical cuts. So this is my 0 degree kerf because this was cut this way. And so even though the part is rotated at 90 degrees, the cuts are being made horizontally, which on my machine is considered 0 degrees. The kerf then for 0 degree is 0.145. And when I used half of that, I used 0.072 and got a nice tight friction fit. Obviously with no kerf offset, I have a nice loose, and there's a little bit of movement in there. Here we'll take a look at the real 90 degree. So this part was laid out this way in Lightburn, but the kerfs are actually the vertical cuts. And this one ended up measuring out to be 0.08, which is pretty small. That's the smallest of all the directions that I tested. And again, with no kerf, I don't know why I keep testing this because they're all going to end up being the same, essentially. But a nice loose fit with the half of that, so 0.04 kerf, just that little bit of a change, that little bit of a kerf offset makes this a nice tight friction fit. My next test I was calling 45 degrees, and it's really 135 degrees or 315 degrees. I had the part at 45 degrees. The kerf cut, however, is this way. So that's our 135 degrees or 315 degree cut. This one came out to be fairly large. It was 0.205 millimeters. And so I did my kerf offset test at 0.102, and it's a very, very tight fit on that. Again, this part was sitting this way in the laser, so the kerf would apply here. I did do one more example or one more attempt. This is a real 45 degree where I had the part tilted this way in Lightburn so that the kerf, or when I'm burning, is an actual 45 degree line. And the kerf on this ended up being 0.115 millimeters. I did not do a finger joint test on this, as they're all turning out pretty well. I just need to remember that when I am cutting a finger joint, or anything, if I want the kerf, I really have to think about which direction the line is going. I'll also need to set up in Lightburn potentially different layers for the different directions. We have quite a difference in kerf setting from our very basic 90 degree, which turned out to be a 0.08, all the way up to our fake 45 that was really the 135, and the kerf was 0.205. That's kind of quite a shift from 0.08 to 0.205. If I need to use kerf for something, I'll need to have that in mind so that I can adjust accordingly. And this is all due to the laser point not being a circle. It's some sort of weird trapezoid shape of some sort. Let me go over to the computer and see if I can illustrate this a little bit better than how I'm explaining it here. See if I can explain this better. when we're burning with the laser, when we're burning straight up, so that's really 90 degrees, and we're burning straight up, so we're going this way, or we could be going this way. The width of the cut that's being made is our 0.081 millimeters. So our kerf would be half of that, so 0.04. And this is where I got kind of messed up. I was calling this my 0, and it's really 90 because the kerf is going vertically. The same thing happens when we're cutting horizontally. So we're basically cutting at 0 degrees or 180 degrees. When we're doing that, our actual cut is something like this. And the number that we came up with was 0.145 millimeters. And again, our kerf would be half of that, so 0.072. So just imagine that this black line this is our laser beam, and it's moving this way. So it's making a cut that's this wide as it's going either at 0 degrees or 180. The 45s are also kind of weird in that when we're cutting a 45 and we're going this way, again, the actual burn is the width this way of our laser. And when I did the 45 in that direction, it was 0.115 degrees. No, it was 0.115 millimeters. Again, imagine this line just pushing forward that way, and that's our burn. What I had originally called 45 was when our laser was moving this direction. Again, our actual cut width is a line that's more along this kind of shape, as it were. And this came out to be 0.205 millimeters. So that was wider than all the rest of them. Our kerf ended up being 0.102. I could also do 0.103. It doesn't really matter in that thousandths of a millimeter. That's irrelevant for the accuracy of our machine anyway. So we just envision this line pushing its way this way, cutting a path, and the path that it's cutting is this 0.205 millimeters. I have to remember that when we're doing this, the cut angle is, depending on which way we're going, it's either 135 degrees or 315 degrees. So when we're cutting this direction, the number that I use is this 205 or 102 if I'm doing half of it for the kerf. Hopefully that makes more sense. I don't know if the illustrations helped or not. If it did, do a comment. It was kind of fun setting up doing the illustration. Another experiment that I did was I took a tile that had the titanium dioxide mixture on it, and I cut some horizontal lines, some vertical lines, and some lines at 45 degrees. I wanted to see if we could see the shape of our laser in doing this and see if there was a noticeable difference in the width of the laser beam itself. Let's go put this in the microscope, and we'll take a look maybe at this point where we have all three of these kind of joining in at one spot, and then we can get a good idea of what this looks like close up. Here we have the tile under magnification. Let's zoom in. Under extreme magnification, the lines really don't look that different. We don't get a good idea of what the shape is of our laser beam, and the width of these lines really doesn't seem that ridiculously different as we were seeing in our kerf offset tool measurements. That was a fun experiment to do. I hope you enjoyed it. If you want to burn out this little tool for measuring the kerf on your machine, I do have the link down in the description for the Lightburn site where you can get the project for this and burn it out. Unless your laser dot is an actual circle, you're going to want to try burning this in different orientations and see what your kerf comes out. I found that in my 4 major orientations, so horizontally, vertically, and 45 in both 45s, I had dramatically different results, anywhere from 0.08 for the smallest amount of kerf all the way up to 2.05, was it? Yeah, 2.05. And if you want to use kerf in your burns, it's important to know what your offset's going to be, and that really depends on what direction that line is going to be cut. I did mess around with trying to draw what my laser dot actually looks like with no success. If somebody can help me figure out how to draw a shape that that matches these odd dimensions, so when I'm cutting vertically, it's going to be 0.08 millimeters wide. When I'm cutting horizontally, it's going to be 0.145 millimeters wide or tall. And when I'm cutting at a diagonal this way, it's a 0.205, and when I'm cutting in a diagonal this way, it's 0.115. Again, tried drawing shapes numerous times and never really got one that tickled my fancy. It's like, these don't work. Anyway, it's probably some sort of trapezoid, not a trapezoid, rhombus. It's some sort of rhombus shape, I'm sure, of some sort. Also, did the experiment where I just burned some lines, put that under the microscope. That really didn't help us discover what the shape is. And under the microscope, it looks like the cut lines are fairly similar in size. And it doesn't really display that variance that we were seeing using the kerf measuring tool, which is going to be fairly accurate because we have 20 cuts that we're adding up to get our overall kerf. That's why we divide by 20 at the end, is the measurement is literally measuring the 20 cuts. We divide by 20 and that gives us our real kerf width. We divide that in half again, and that gives us the offset that we would use within Lightburn. If you like this video, give it a thumbs up. And as always, if you like the content of our channel, please subscribe, as that does help us out. Enjoy doing your CNC at home projects. And download this one. It's a good one.
Oops.